Okay, so good afternoon, everyone. Today we'll be starting the topic on regression. Last session we did the topic of correlation. So today we'll be discussing the concept of regression. Okay, now regression basically indicates how much are two quantities correlated to each other. Previously we discussed that whether or not two quantities are related to each other, whether or not two quantities are correlated to each other, that measure is given by the concept of correlation coefficient. Similarly, we'll be studying the concept of regression today, where we'll try to understand that how much are two things related to each other and what is the effect of change in one quantity on the outcome on the other. So last time we were capable of understanding whether or not two quantities are connected to each other. This time we'll try to figure out if two quantities are connected to each other, then by increasing x, how much should the value of y increase? So suppose the value of x increases by 10 units, the value of y should increase by how many units? This is the concept of regression. Let's start with the definition first. Regression is the measure of average relation between two or more variables in terms of original units of data. So you need the original unit of data depending upon which you can predict the future variables. Regression analysis is the statistical tool or the study for the nature and the extent of the functional relationship between two or more variables, and it is used to estimate the unknown values of independent variable given the value of dependent variable. What we mean by saying that is, suppose y depends upon x as per an equation y equal to 5x plus 7, then by putting in the value of x we can predict the value of y. So given the value of x we can find the value of y. This is called regression analysis. Okay, so we can predict the value of y given the value of x. Now doing this, there will be two variables. First will be the dependent variable and the second would be the independent variable. Suppose we are given an equation y equal to 2x plus 3. In this equation, if x is the independent variable, then y is the dependent variable, which basically means we can get the value of y on putting in the value of x. Okay, we can have the equation in the reverse order as well. We can have x is equal to 3y plus 4. We can have x is equal to 3y plus 4. In this case, y will be the independent variable and x will be the dependent variable. So when we put the value of y this time, we'll get the value of x. So basically it is either ways, we put the value of x, we get the value of y. We put the value of y, we get the value of x. Okay. Does anybody have any queries so far? Okay. So next comes the uses of regression analysis. What are the utilities, the uses of regression analysis? Now this regression line facilitates to predict the value of the dependent variable given the independent variable. We have already discussed that. Through standard error facilities, we can use it to obtain a measure of the error in using the regression line as the basis of estimation. So using that as the basis of estimation, we can find the error involved in the regression. Okay. Now there are two coefficients in this entire scheme of things. The first coefficient is the regression coefficient x on y. So we have it represented by b, small b, xy. Similarly, the second coefficient is b of y on x, which is represented by b suffix yx. These help us in calculating the value of coefficient of correlation, which is small r, and they are connected to each other using a formula which we'll be discussing very soon. The formula says r square is equal to bxy times byx. For details, we'll be coming to that very soon. Next is regression analysis is a highly useful tool in economics and in business in general. Now, the distinction or the differences between correlation and regression. For correlation, it measures the degree and the direction of the relationship between two variables. It measures the degree, means the amount, and the direction of the relationship between the variables. Regression measures the nature and the extent of the average relationship between the two variables. Okay. Correlation is a relative measure. It only shows us the association between two variables, whether the two variables are related or unrelated. Regression, on the other hand, is an absolute measure of the relationship. By that we mean when we put in the value of x, we'll get a value of y. In case of correlation, we only get whether they are connected or not, or whether they are strongly or weakly correlated. Okay. Next, the third difference between the correlation and regression. Correlation coefficient is independent of both the origin and the scale. It neither depends upon origin nor depends upon scale. Correlation coefficient is independent of both origin as well as scale. Regression is independent of origin, but it depends upon the scale. Next, correlation coefficient is independent of the unit of measurement. Correlation coefficient does not depend upon the unit of measurement. Regression coefficient is dependent upon the unit of measurement. Okay. Interestingly, the value of correlation coefficient should always lie between -1 and +1. The value of correlation coefficient should always lie between -1 and +1. And the value of regression may be either linear or non-linear. And since it is an equation, so there is no question of a value. Correlation, it is not used for forecasting. You cannot predict using the value of correlation. Although using regression, we can predict or forecast certain situations and values. Does that make sense? Any queries, anyone? Now, regression lines. What are they and how do they look like? So, regression line of x on y, regression line of x on y is represented as x is equal to a plus by. X is equal to a plus by. This is the regression line of x on y. So, suppose x is the dependent variable and y is the independent variable. X is the dependent variable and y is the independent variable. Then a and b will be the x-intercept and the slope. Sorry, a will be the y-intercept and b will be the slope. Now, another way of representing the regression line, x on y. So, similar to the concept of straight lines, the equation goes x negative mean of x equal to bxy, which is the regression coefficient of x on y, times y negative y mean. The value of bxy can be calculated as r times, r is the regression coefficient, times, sorry, the correlation coefficient, times sigma x over sigma y. So using this simple calculation, we can easily find out the value of the equation, which is x on y, and then on putting the value of y, we can easily get the value of x. Do we have any queries so far? Now, regression coefficients. Regression coefficients. There are two regression coefficients as we have discussed. They are byx and bxy. How do we calculate the value of byx? Byx is equal to small r, which is the correlation coefficient, times standard deviation of y by standard deviation of x. Similarly, the regression coefficient of x on y is bxy, which is equal to r times standard deviation of x by standard deviation of y. Now, interestingly, when we multiply these two terms, byx and bxy, we get r to the power 2, r square. Okay. Now, what will be the regression line of y on x? The regression line of y on x should be represented by y equal to a plus bx, where y is the dependent variable this time and x is the independent variable. A is the intercept and b is the slope of the line. Okay. Now, the other way of drawing a regression line of y on x is to write it as y negative y mean equal to byx times x negative x mean. So y negative y mean equal to byx times x negative x mean. Now, instead of byx, we can also write r times sigma y by sigma x. R times sigma y upon sigma x. Do we have any questions? Properties of linear regression. The two regression equations that we were talking about, in all there are two regression equations that we were talking about. The product of the regression coefficient we have already discussed, that is equal to r square. So let us take them one by one. The angle between two regression lines, if there are two regression lines, the value of r gives us the angle between the regression lines. If the value of r is equal to 0, then the regression lines are perpendicular to each other, means the angle between the regression lines is equal to 90 degree. Similarly, if r is equal to plus 1 or negative 1, the regression lines coincide to become identical. So we get the same regression lines basically. Please feel free to ask if you have any questions so far. As we were discussing earlier, the property states, there is an important property which states that the variables x and y may be interchanged into new variables, let's say u and v, and we can find that the coefficient are independent of origin, but they depend upon the scale. So suppose we interchange x as x with u, so we get x is equal to a plus pu, solving which we will get u is equal to x minus a over p. Similarly, v will be equal to y minus c over q. Now, the coefficient of uv will be equal to q divided by p times b of xy. Okay. Similarly, the regression coefficient of vu will be equal to q divided by p times b of yx. Okay. Now, regression line y on x, as we said, can be represented as y equal to a plus bx. Now, the two normal equations are summation y, taking a summation on both sides, we get summation y is equal to na plus b times summation x. So basically when we take a summation on the both sides of the equation, y would be transformed into summation y, a would become na, and x would become summation x. So my entire equation becomes summation y equal to na plus b times summation x. Similarly, from the first equation we can write summation xy will be equal to a times summation x plus b times summation of x square. Next, the formula to calculate byx, which is the regression coefficient of y on x, is summation xy negative summation x times summation y over the number of observations. Entire thing divided by summation x square negative summation of x whole square over number of observations. It is also worth noting that from the previous equation we can write a is equal to mean of y negative b times mean of x. So substituting the values on the right hand side, we can get the value of a. Same concept applies for the regression line of x on y. Applying which we can get the two normal equations. Normal equations would be summation x equal to n times a plus b times summation y. Similarly, summation xy is equal to a times summation y plus b times summation of y square. Same set of formulas, just x will be replaced by y and y will be replaced by x to get the new set of formula. So this is how we calculate bxy and byx. Does anybody have any queries so far? Now population linear regression model. So basically we are aware that y is equal to a plus bx is an equation where y depends upon x. This is an equation where y depends upon the value of x. Now, in such an equation, there is a probability of creeping in a small random error. That random error is represented by the epsilon in this equation. Okay. So remember at the beginning of the session, we were talking about the error. This is exactly that thing. Any queries? Anything you would like to ask? So let us take a question to understand things in perspective. We need to calculate the coefficient of correlation from the given set of data. So we have been given certain values of x, we have been given certain values of y. We need to calculate the coefficient of correlation between x and y. So let us take up the process. So the values of x are tabulated in the first column, the values of y are tabulated in the second column. Knowing the value of x, we can easily calculate x square. Knowing the value of y, we can easily find y square. We know x, we know y, we can also calculate xy. Once we have the set of values available to us, we can put the values in formula number 1 and formula number 2. We get a simultaneous set of equations. Solving this set of equations simultaneously, we can get the value of small a and small b, which are my regression coefficients. Now when we put the value of a and b in the equation, we get the relation between x and y. Putting the values back, we can find the identified values. Let's say in this question they have asked for the value of the likely sales when the advertising expenditure is 7 lakhs. So sales would be the value of y and expenditure would be the value of x. So when we put the value of x as 7 in the regression equation, we'll get a particular value of y. That value of y becomes my answer. Okay. Does anybody have any queries? Anything you would like to ask? Okay. So in the next session, we'll be taking up another new topic. Till then, good day.